Welcome. The title of today's lesson is Operations with Functions. Just like we can perform the 4 basic operations on numbers, we can perform the 4 basic operations with functions, and that's exactly what we will be doing today. Addition, subtraction, multiplication, and division. What I tried to do is just come up with a context for doing that. This is an application that you see at the top of your page, but it's very contrived in nature, but I still think it should suffice in telling us what to do and how we would do it and why we would do it and so forth. And then we can go ahead and do a couple examples on the back side here. So why don't we dive right in and get this investigation underway. So it looks like I have 2 functions, both cubic in nature, that model the crime in city A over a time period and the crime in city B over a time period. Sounds good? And so year 0, by the way, just if you're reading this, would represent year 0 would be 2000. And so what we're going to do is manipulate those a little bit. We're going to perform operations using them and see if we can create other functions using those. Well, here we go. Number 1, write a function to model the combined number of crimes for both cities between 2000 and 2005. So in this case, we have the crimes in city A and the crimes in city B. How can I mathematically define the crimes in both cities? What would I do to those 2 original functions? And I am hoping you would be in agreement that we would essentially add them together. Here are the crimes in city A. If I add the crimes in city B, I get a new function that would describe the combined number of crimes in both cities. Something along those lines right here. Again, just basic operations instead of on numbers. It's really just on functions. So I'll go ahead and play this out, and I would encourage you to do the same. If you don't feel the need to jot down every single thing here, I can definitely live with that. But basically, I'm going to take this right here. There's f of x, crimes in city A, and just add on the crimes in city B. There we go. I'm almost there. Okay, and there you go. And how do we add polynomials that look like this? These cubic functions fit in that polynomial family. Well, I'm hoping you kind of remember that we would basically combine like terms. So think about this many x cubes plus this many x cubes. So apples to apples, oranges to oranges, right on through. And I guess when all is said and done here, we combine all of the x cubes together, the x squareds together, the x's together, and the units together. And what that should give us is a mathematical function for f of x plus g of x. Now I have this written on my paper here, so I'm going to go ahead and pull this off. But this plus this should give me 1.31 x cubed. Good. Now the x squareds. This plus this should give me negative 9.03 x squareds. All right, I'll keep going. This plus this right here, I'm getting 60.64 x's. And last but not least, add the units together, and I get that. And that's it. You're basically creating a third function from the original 2. Wonderful. Now, let's go ahead and pull this off. It says use your combined function, so use your answer from number 1 to find the total number of crimes in 2005. Well, now that we have this function right here, if I gave you any particular year, you could answer exactly this question, the combined number for the 2 cities. In this case, of course, year 5 would be the 2005, so we're going to put in 5 for this right here, and I'll go ahead and do it, and you do it as well, and let's get our value. So bring up that calculator if you can, and here's what I'm thinking. 1.31 times, and again, it's the 5th year of the model, so just comfort level dealing with inputs and outputs. So I have that piece right there, minus, and then let's go ahead and do the same, 9.03, in this case 5 squared, and then plus 60.64 times 5, and last but not least there, I'm getting a 1240.97, give or take. And there we go. So if we essentially get this, and I'm going to go ahead and write our notation out a little bit here as we kind of put this together, but basically, and by the way, this is a different way to do notation for f of x plus g of x. So in this case, I'm doing the f of 5 plus g of 5. And once I have my function, again, that just went into this x value right here. So again, I use my combined function. 5 is the input of our combined function. And again, just don't worry too much about this. This is the same as f of 5 plus g of 5. It's just consolidating the notation there. Just kind of get used to that. You'll see that on the back side as well. But let me go ahead and quickly get rid of that, lest it get in our way. And I think we saw something around 1482 on the calculator. Didn't get a great look at it, but I'll go with it. So about 1,482 crimes in both cities in that particular year. Now again, this number for number 3 is going to fall outside our model, so it's a prediction. So total number of crimes for 2009. Hey, let's go ahead and do that on the calculator as well. 2009 would of course be year 9 in the model. And so now you're just making a prediction for it. And here's what I'm going to do. Well, you know what, actually I'll type it all the way through. So one more time. So in this case, 9 is the input. Make sure I get this right. And you're either, well, I'm hoping you're typing it in with me, getting just comfortable dealing with that piece. So year 9 now as opposed to year 5. And that's the idea. We combine the two functions together to create this third. And what it modeled, of course, was the total number of crimes in a particular year. And I'm getting that right there. Just want to make sure everything is typed in. And it looks pretty good. I'm getting about 2009. I'm going to go ahead and put that in place. So this would be, and again, just kind of ballparking. It doesn't have to be perfect by any means. Just manipulations of functions. That's all, everybody. Don't overthink this piece. We're adding. We're going to do some other ones as well. All right, so once we combined our two functions together to create this combination right here, then we utilize it. Given an input, we can come up with the output. Nice. All right, let's see what we're going to do next. Again, just kind of working with these two original functions, so f of x and g of x. Now, if we were to graph, I will tell you it is definitely apparent the crime in city A is greater than the crime in city B. So it says based on f of x and g of x, it is apparent that city A has a greater number of crimes for the years covered in the model. However, is the gap increasing or decreasing? Write a function that will help answer this question. Wonderful. So what I'm looking for is sort of to find a way to get the gap between the crimes of the two cities. Another way for me to say it, without hopefully giving too much away, is I want a function that will provide the difference of the crimes in the two cities. Difference. And what operation, of course, do we talk about when we refer to the difference between two quantities? And that would be subtraction. So this, I believe, when all is said and done, is going to be f of x and then minus g of x. There we go. Sorry about that. Lost my train of thought there for half a sec. Now I've got it. And so what we're going to do is take the original two functions and just subtract them. So same deal. I'll write it in. If you don't feel the need, so be it. But let's go ahead and make this happen at least on my board here. Got that. So now basically just taking these two and subtracting them together. And again, city A apparently has more, so we're going to do city A minus city B. And so I'm going to get this piece right here, x cubed. I've got to look at my paper. You have it on your sheet right in front of you. It's a little tougher for me, but I think I can pull this off. All right. There we have it. Looks good. And so this would tell us the difference of the crimes in between both cities there. And so, again, how do we deal with polynomial subtraction? Well, just apples to apples again. Just be careful. This minus right here is a tricky thing to deal with. So just remember, it's minus each and every one of those terms. Put that in place. Well, I'm going to go ahead and give you what I have here just when I combine the like terms, and then you can kind of take it for what it's worth there. Looks like we're going with about a negative 2.49 x cubed. And I've got about 17.91 x squareds minus 60.26 x's. And on my paper, it's tough to read it, but I'm getting about 344 and change on the back. Something like that. And so this would be f of x minus g of x. Again, just another way to see that, everybody. This is the notation that goes with it as well. So don't get panicked if you see something like this. These two mean the exact same things, just two different ways to write it. Okay, so we created a third function from the original two, just via subtraction. No big deal. Let's go hit number 5. Use a graphing calculator to graph your function from problem 4. Is the gap in crimes between the cities increasing or decreasing? Is there a projected year when crime will be the same? And if so, what year? Okay, kind of cool. Let's go for it. Let's get some experience with these graphing calculators and kind of work with them a little bit. So I have a function that I'm going to type in, and then let's see if we can work with it. I have negative 2.49 x cubed. There we go. And then plus 17.91, and I see x squared on that, minus 60.26 x on that one, and we said 344.01 to end. All right, that's looking pretty good. Now, guys, let's go to the window there. Keep working with this. And what we have is a relationship. What we've developed is a relationship between the number of years that have elapsed and the difference in the crimes of the two cities. Okay, so first and foremost, let's go future. So start at 0, and I'll go out to 10. If we need to go further, we'll do that. But let's go 10 years out. And then in terms of the difference, well, we already kind of figured out that the difference between the two is at least some positive value. And then we want to see when they will be the same. So I'll tell you what, I'm going to go 0 right there. And I don't know what the difference is in this particular case. I'm going to go up to about 500. I don't know if that's, I sort of see hundreds on the back end. To be honest, it's a lot of trial and error dealing with Windows. But let's see if this one worked. Let's see if I was on the right track. Actually, wow, that was a really good window. So remember what let's analyze this. Remember what function we created here. It's to talk about the difference of the crimes in both cities. So initially, this is the difference of the crimes between city A and city B. And then look at what's going on with the graph here. Is the difference increasing or decreasing? Well, it looks like the difference or the gap in the crimes is decreasing, and it's going down, it's going down, it's going down. Would you all agree with me that at this stage right here, what is the gap between the crimes in the city? 0. It looks like that's what's happening here. Initially, there is a pretty severe gap in the crimes. City A has quite a bit more crime than City B. And then what happens is over time, the gap starts to go away. And then at some point, the gap disappears entirely. All right. So let's answer a couple questions with this, and then we'll go back to the screen. Is the gap in crimes between the cities increasing or decreasing? Definitely decreasing. Is there a projected year when crime will be the same? If so, what year? And let's go ahead and kind of bring that out. So here we go. Look at the tick marks: 2001, 2002, 3, 4, 5, 2006. So does everyone kind of see that? There is a way to get this on the calculator. Haven't taught that just yet, but we will be doing this in the future. For right now, I'm going to leave it alone and just kind of project a little bit. I would say it's somewhere in between, 2006, 2007, somewhere in there. So I'm going to just write down 2006, and we can move forward. So I hope you see kind of the context for subtracting two functions, kind of the difference between them. And then we utilized it a little bit, which I think is great. Cool. All right, let's go see. We've done some addition. We've done some subtraction. Let's probably do just one more. Being able to calculate the number of crimes is helpful, of course. Good social statistic, number of crime in a particular city, but it doesn't tell the whole story. We don't know if City A is the size of Nederland, Colorado, or if it's the size of New York City. So here is additional information on the population of both cities. So here are what we would call exponential models. Population of city A right here, population of city B right here. Okay, awesome. And by the way, you can see just from the numbers here, city A does have more people in it. So it says, for number 7, a useful statistic when investigating a problem of this nature is to determine the per capita crime rate. So not just the number of crimes in a particular city, but actually the crimes per person. So per capita crime rate. And so crimes, we have actually functions that refer to that mathematically. We have now a function dealing with the number of people and everybody. What's the operation that goes with per? So crimes per person. What operation would you think about when you see this right here? Well, I'm thinking division. So the number of crimes divided by the number of people would be the crimes per person. So I'm just going to write division right here, by the way. And you can see our third and last operation that we're going to do here with this investigation. So it's going to get a little hairy with the graphing calculator. The good news is division we're not going to do a ton with. So in this case, everybody, it's going to look like this. F of x divided by g of x. Sometimes you see it like that. So that would be f of x divided by g of x. And guys, it's going to look ugly, 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 but it doesn't matter. So do we have the number of crimes? Absolutely. In fact, actually, I should be careful on this. It's not f of x divided by g of x. For this one, it is f of x divided by p of x. My fault on that. So now we're dividing those two functions. So we're combining two other functions there. Glad I caught that for us. And so that's what we're going to do. Take f of x and divide it by p of x. So let's do exactly that piece. And let's get that going. So guys, f of x, we know. It's the top. And so let's put that in place right here. 4 x squared. You guys do the same. You're probably quite a bit quicker at this than I am. Okay, nice. And we're going to divide that by p of x, which was defined as 61,000 times 1.018 raised to the x. Now, it's a pretty comprehensive function here. My goodness. Let's leave it. Let's leave it just like that. Now it says, write a function for the per capita crime rate in city B. So this would be g of x divided by q of x from what I saw. So something like this is what I have in terms of the notation. Hope everyone agrees on that. Crimes in city B was represented by function g. Population of city B was represented by function q. And if we want crimes per person, we divide. Wow, awesome. Here we go. So I have this right here. Please do the same on yours. And then here's the only issue, and it is going to be a huge one, everybody, but bear with it. I know you can. We're going to have to get these in the graphing calculator. I'm willing to do it. I hope you are as well. Okay, so I have 28,000 on the bottom, and we're going to look at exponential functions in a lot of detail coming up second semester, but for right now, that's it right there. Oh my goodness. Okay, so division, huh? One over the other. Let's go get number 8. Graph each function on the graphing calculator. Use the window range, scale, and all that stuff. Which city seems to have a stable crime rate, and which city seems to have a crime rate that continues to increase. All right, let's go ahead and compare. So we've created these functions from the originals. In this case, we created it via division. And now what I'd like to do is see that graphically. I'm going to bring this over here in order to get these in. And my goodness, are you guys ready? You can do it. I know you can. So here's how it plays out. Parentheses around the whole numerator, and then parentheses around the denominator. So here we go. A little race, if you would. So we have this. Okay, I'm going to keep typing this in. Please do the same. So that would be f of x. Now we're going to divide that. Oops, I think I missed something right there. Let's go ahead and fix that. So insert a plus. There we go. My bad. Okay, so let's make sure I have that right so far. Yeah, you have to always be careful on these. I am as apt as others to make mistakes typing stuff in, so be a little extra careful. And now parentheses around the bottom, 61,000 times 1.018 raised to the x. And is it pretty? No way. But will it work? Let's hope. Hey guys, let's go get the next. So parentheses around the top, same deal. Let's go get this other per capita. Got that right there. Okay, I'm rolling. It's looking good. Missed a decimal on that. Let's go fix. Let me make sure. I missed one again. Got to be careful. So that is a plus right there. I'm going to insert a plus. Let's make sure. All right, I'm feeling a little better about it. Now divided by, here we go, 28,000 times 1.0. Oh, I missed that times too. Let's see, times 1.021 raised to the x. Whew. Goodness. All right, now if I remember correctly, we go to window. And we're going to go from 0 to 10 on the x's, go by ones. Absolutely great. Then on the y's, we're going to go 0 to 0.1, and we're going to go by 0.01 there. Fascinating. All right, let's get it in. Moment of truth. There's one. Oh, and this worked out great. So this was the per capita crime rate in city A. Pretty stable. This is the per capita crime rate in city B. What does it tell us? That it's increasing potentially over time. Does everyone kind of see that piece? So notice, analyzing the graphs of the two, and each one really related to per capita crime rate. All right, so city A, I would call it stable. I hope you saw that piece. And city B seems to be the one that's increasing. All right, so again, it's just working with particular statistics and how functions are defined mathematically. And again, the bottom line here is, as we go through this notes worksheet, combining two functions together to create a third. Okay, so we saw a nice context. I kind of like it. It took a little time, and is it perfectly relevant? No. But again, in my opinion, we at least see how and why and what we would do when we combine functions with addition, subtraction, multiplication, and division. We didn't see the multiplication in action, but 3 out of 4 is not too bad if I do say so myself. All right, let's go for it. Nice and easy. Let's just go back to a couple families of functions, working with those. And so this basically just says take f of x and add g of x. So now just kind of the rote algebra, so to speak, just working with the skills on this. Let's go ahead and get an LCD here. I'm seeing this, and I'm going to have to come this way. Don't particularly like working horizontally with this, but I don't have too much of a choice. Least common denominator, everybody, should be x plus 2, x minus 3. And remember, just good practice adding fractions together. How did you change the denominator? Old to new. Looks like I took that and multiplied it by x minus 3. So I do have to compensate on the numerator, multiply it by x minus 3. Same one over here, guys. Looks like this is the old denominator. Here's the new. I did take that and multiplied it by x plus 2. So guys, of course, you're going to take that and multiply it by x plus 2. Clean that up for me. You can be quicker than I can, I'm sure. You can do it. So in this case, this is what I'm getting. How about an x squared minus 3x and then plus, and this looks to be, and I'm just going to be careful with this, how about x squared plus x minus 2. And all of that's over x plus 2, x minus 3. Good skills right here. Make it happen. I'm getting a 2x squared minus 2x and minus the 2 from what I see. Just be a little careful on that. I need to be as well. And how does x plus 2, x plus 3 sound down on the bottom? All right, I could see factoring out the 2 there, but I don't really see any point to doing that. At least I'm not catching one. So we'll go with that as our final answer. Cool. Hey guys, can you subtract two fractions? Of course you can, and that's all that's required here. So it's f of x, which is defined as this, minus g of x, which is defined as this. Do you happen to notice it's going to be the exact same, except instead of a plus here, it'll be a minus? So I'm hoping, obviously, you would see same format. So if it's all right with you, my apologies for doing this, but, you know, might as well save a step or two if we can. We would get here, except with the minus, and we get here with the minus. So I'll go ahead and do that, plus x and minus 2. And that's, of course, over that common denominator, which was x plus 2, x minus 3. All righty, very cool. This shouldn't be too bad. X squared minus x squared does cancel. Just be careful. Negative 3x minus x is negative 4x. And minus a negative 2, or kind of a 0 minus negative 2, is plus 2. And over x plus 2 and x minus 3. Again, I could see us pulling out a 2 there, but you know, I do get a negative x plus 2, which is different than this. I see this as a legitimate expression for that function right there. Okay. Let's go get this one, multiplication. Not too bad. So it's just this times this. All 4 operations and fractions in one shot here. I kind of like it. Hey, how do we multiply? Well, we do, of course, look for common factors to cancel a numerator, denominator, maybe cross-canceling. I don't see anything, and so let's just multiply across. Sorry, guys, I'm going to just have to bring this right down here. I'm just getting an x squared minus x on top, and if you left it in factored form, that's fine. I don't care. And then x squared, how about minus x minus 6 down on the bottom? Just foiling this out right here should give us that. And again, if you left it as just a product of 2 factors, no harm. Cool. Last one here, and then we get into one more. Good graphical problem, by the way. So f of x divided by g of x. If you can work with it, great. Do you remember that crazy, crazy investigation when we did the per capita crime rate? How insanely complex the function that we created was. Not much really doing there. So just work with what you have. I don't know, I think I maybe have shown you the outside over inside trick when you get a compound fraction looking like this. So you take the outside terms, multiply them together. So that would be x times x minus 3 over the inside terms when you multiply those together. I like that. To me, it's a nice, quick way to do it. Outside over inside. Or, again, dividing by a fraction is the same as multiplying by its reciprocal. So you can bring this on up and write it as its reciprocal and multiply it just like we did here. This would just be x minus 3. This would just be x minus 1. Hey, no big deal regardless. I think you just get that, and it shouldn't be too much of a dramatic issue. Okay. Well, look, we had 2 what we would call rational functions. And I used the original 2 to create a third with addition, then to create another one with subtraction, create with multiplication, create with division. That's all. Awesome. Hey, let's go get example 2 and round this out. I like this one. Just again, it's just all getting comfortable with functions, this whole unit. Manipulations, operations, expressions that go with them, all that good stuff. So here we go, example 2, use the graph to find the following. So f of 1 plus g of 2. So I'm going to take a couple values and add them together. Not much of a huge issue. Let's just make sure we understand what this means. 1 is the input. 1 goes into the f function, and I get an output. Now, I don't have an equation for it. I have a graph for it. So remember, input, and we want the output. So if the input is 1 on the f function, and by the way, here's the f function right here. If the input is 1, that means the x is 1. So here's where the x is 1. And let's go to the f function right there, the graph of it, I should say. And everyone, what is the output? F of 1 equals 2. And so there you have it. This is just 2. Plus, so now I have one output added to the other output. Again, guys, get comfortable. Input is 2. It goes into the g function. So let's see what we get. Here's your g function. Input is 2. And when the input is 2, it looks like the output, everybody, or the y value would be -2. And so what I'm seeing is just 2 plus -2. And that equals 0. And that's it. That's all I'm looking for there. Awesome. Let's keep going. F of 3. Here's f of 3. So input is 3. Output, everybody, it looks to be 6. Hope you see that. F of 3 is 6. So 3 comma 6 on the f function, essentially. Input, output, minus g of 3. So here we go right here. Here's 3, and we go on down, and I'm seeing this as -3. So 6 minus -3 is then 9. All righty, quick one right here. Let's go get it. F of 0, 0. G of 0, 0. So it looks like they both go right through the origin. Not a big deal right there. Again, guys, it would be great if you can kind of beat me to it, just analyzing the graph. And here's what I have, f of -2. All right, so here's the f function. -2 is the x. It goes into the f function, and I'm right here on the function f, and I get -4. F of -2 is -4. G of -1. All right, let's make it happen, everyone. That means the x is -1. We go on the g function, and of course, as you can see, I get 1. -4 plus 1 is -3. Can I really do this with any combination, any operation? Yeah, of course, of course. Great. Let's do one more good one with this. Example 3, and we'll wrap it on up. It says, use the graphs of y equals f of x and y equals g of x from example 2 to draw the graph of y equals f of x plus g of x. So let's go ahead and create or draw the combination function from the graphs of the original 2. Then, a little extra here, let's see if we can write an actual equation for it. So here's what I'm thinking. Let's just kind of go through briefly a couple of the x's here, and let's see what happens. So let's do this. I think we already have this in place. So if I do f of 0 plus g of 0, which we did, 0 plus 0 happens to be 0. So as a matter of fact, f of 0 plus g of 0 is 0. That would be a point when I add the two together. That would be a point on the new function. All righty. How about this one? What would be f of 1 plus g of 1? Let's take a quick peek. So guys, f of 1 happens to be 2. G of 1 happens to be -1, right? So f of 1 and g of 1. What would happen if I add those two values together? I'm combining those two values together, and it looks like I would get 2. This is 2. This is -1. So 2 plus -1, and I'd get 1. How does that look? So as a matter of fact, that is a point on our new function. All right, great. One more just for kicks, and then let's go ahead and bring this to a conclusion. How about this one, guys? What about like f of 2 and g of 2? And these are arbitrary, but let's see what would happen if I added the two together. Hey, guys, here's an input of 2. f of 2 is 4. G of 2 is negative 2. 4 and negative 2, if you add those together, 4 and negative 2 would be 2. So basically, if I add this and this to create the new y value, I would be right there. Could I continue to do this? F of 3, f of 4, f of anything, all the way through? Absolutely. And would you get a line that probably looks something like this right here? You bet. And long story short, there is y equals f of x plus g of x. Awesome. Could you write an equation for that? Hey guys, it's just a line. We haven't really talked through linear models just yet, but you know, hey guys, just y equals mx plus b. You can probably do this in your sleep. What seems to be the slope there? Up 1 over 1, up 1 over 1. So it looks like y equals 1x. And yeah, it looks like the y-intercept is 0. So y equals 1x plus 0, or better yet, just y equals x. So there are multiple ways to kind of pull this off, but it's just kind of interesting to see you're combining these together. And if I did this an infinite number of times, it would create all of the points on this line right here. Awesome. Alrighty. So we took a lot of time here to develop the idea, but let's just break it on down. Very simply, if you have functions, you can add, subtract, multiply, and divide. And we looked for the context and the sort of the mathematics behind that. All right, thanks. This is some good stuff here. Try a few out and let me know if you need some assistance.